Hello Internet, today we're going to be going back to our Observer project, which is a way to use, it's a tool for Unity that allows you to find a group of objects by name, or hopefully other things, but right now by name, and then display a property of them together. So normally you'd select three lights, right? And you'd move them around. That's great, but if I want to see where all of those lights are in my scene, I can't do that without cycling through all of them or writing a script to do that. So this tool actually does that. So you can see I already have it pulled up here. It's right next to the hierarchy. And so I've done a little bit of extra editing. The name of the window has changed. It's now just Observer instead of the actual class name, which didn't make any sense. And I've removed the title here, so it's just a straight text box. But the idea is you type in whatever you want to find. Let's say I want to find the main camera. It's going to come up with the main camera, and you'll see it updates it as we type. Then we can do all of this other fun stuff. So I see the position. We can do that for lights as well. This should be fairly familiar if you're familiar with the tool. I'm just kind of going through this again because I've changed a few things behind the scenes. And so two things have changed. One, the name is different. So it's now called Observer instead of Observer Editor Window, which is just gross. And so also I can close it. And now if I hit Control tilde, it pops back up and I can do all the same stuff again. And so that's just a really quick hotkey. If you've seen the Unity shell, we added the same hotkey there as well. It's pretty easy. The way to do that is through the menu item. When you're actually adding the menu item, you can add some extra stuff at the end. And that extra stuff in this case is a %tilde. And percent is a special character in this case, and it means on Windows or Linux. I don't think Unity is on Linux, but on Windows, it means control, and on Macs it would mean command, just because they do things differently. They think differently. Anyway, and then there's just a tilde, so it's just a chord. Is that what they're called? Anyway, control tilde opens it back up, and that just gets handled by Unity. The editor itself actually picks this up as well. So you can see in when I go to Tools/Observer, it actually comes up with the hotkey there, so you can actually get some prompts and actually memorize that more visually. But that's all besides the point. What we're doing in this video is making it so we don't just get this transform position. So right now, the only thing we can get is transform.position. It's hard-coded right here. We want to get rid of that. So the idea of this is to, I don't think we're going to get to the point where I can pull out any object. I want to be able to pull out any vector3 field though, and render it here. Vector3 because we already have that working, and it's just there. But the idea is we're going to have a component that we can actually use and find things with that. So that's what we're going to be working with. There's a few things that we need to do. One, we need to actually get all the components on all the objects we find. Because right now, every object has a transform, so it's really easy. But if I want to get like the color of all the lights, that needs to actually get into the light component, and that means it actually has to exist. So first things first, we need to actually find all those components. There's an easy way to do that. GameObject.getComponents. And now you could give any component type you want here. So if I wanted to only find the lights, we could do that. But that doesn't work because I don't just want the lights, I want all the components. Because we're going to have search terms, and so the idea is we're going to match them by string. Can't do that with a generic type because it's a type, not a string. So we actually might be able to do that by converting a string into a type and then doing this. But I don't want to do that. So instead we're going to use a base component, which if you actually go into GameObject and dig into that a bit, this might take a bit, but the idea is game objects, not game objects, but main components will extend a bunch of things. And you can see all of these things are going to be components. So if there's a rigid body attached, or a camera attached, or an animation attached, or a transform is its own thing, but it extends a component. And then there's all these other things, particle systems, etc. All of its components. It's Unity's base everything. And so this is going to get all the components attached to that specific object. That'll include transforms, but it'll also include any custom components you put on there, which is great because it means that now, after I call this, I have all the components. If you want to get them all in the children as well, there's a in children, I think. Yeah. And that'll pull it out from all the children of that component. That's great, but we don't need that. So let's, just to kind of prove that this whole thing is working, let's do components is equal to that, and we'll just print all of them out. So for each component in our components, let's just do components dot, that's not what I want to do, debug log the component. And so that should just print out all the components we find. There will be a little bit of extra stuff found because that's just how this works. But you can see we get all these directional lights because it modifies it and actually gives the name of the class, plus then in parentheses, Unity transform or Unity light. And so that's what we want. I don't really want Unity engine.transform. That's the full path. So this is actually namespace and class. I just want to match on the class name. And so the idea here is instead of doing light, we're going to add another box below this that's going to be light, which is what you're searching for. And then I want the transform.position. And so the final component is going to be a field or property that you're going to find. And the first one is going to be, or this actually could be multiple, I think. But the first one is actually just going to be whatever you're drilling into. So in this case, it would be light, and then underneath it would be transform.position. Like, let's just set that all up so it makes more sense. Not really going to worry about the name itself. We're not going to store this anywhere. I'm just creating a text field. Eventually, this will all be, the goal is to make this a query language where you can actually just write these and do really complicated things. But we're starting small. So the idea here would be you do transform.position. Probably it's going to be cap sensitive. So since classes are capitalized, you'd start that with a capital letter and then lowercase. If I deselect it, it's going to go away because we're not saving it anywhere. But you get the general idea. We do light.transform.position, and this would be the results we'd expect. Now, theoretically, you'd also be able to do like dot rotation or scale, local scale, things like that. And then it would get you all the scales of all the lights. Not really sure that's useful. Don't know why you'd need the scale of all the lights, but it's an option. So that's where we're going. To do that, we're going to need reflection. Reflection is magic. That's the best way I can think of to describe it. Basically, every class is going to have a bunch of data about itself. It's sort of part of the magic of .NET or Java or any of those other like runtime-based languages. I don't know if that's not the right word for it. But anyway, these classes are going to be storing a bunch of metadata about themselves. You can access that metadata or even change it if you really want to. And the way you do that is through reflection. So reflection is going to let us access, say, properties or classes or fields or any of that other stuff as their raw like C# types, which means we can actually access those and change them, or access them and see their values and then link to them like we're going to do here. So what we need to do first, before we do any of that magic, is do a private string observed type. And for now, we're just going to do observed type whatever. I'm actually going to get rid of all of this, and we're going to just do this for transforms. starting even smaller. I think that's probably a good idea because this might go. I struggle to estimate the size of reflection tasks, so this is probably bigger than I thought. But anyway, we're going to start with the transform. And so you're going to be able to access any field from transform, which means you don't actually need to do any of that complicated query. We're effectively cutting out the transform.position, and then you just type position here, if that makes any sense. So this way it should be a little bit faster. And then in the next video, we can actually add that finding the correct component bit. I think that makes more sense. On the fly changes to scope, but okay. So we have our component and we have the transform. Now I need to get the type of that. And now that I have the type, we can access all the fun stuff about it. So the way this works is there's all of this stuff here. So the easiest way is just going to be calling like get field. If I do get field of our observed type, let's say observed field. That's a much nicer name. So observed field, we'll do that and assign it there. And I just realized my editor is super small. That's probably much better. So now that you can actually read it, this is where we're at. We have our observed field with the text field equal to this, just another copy of the observed name. We also have our component get type get field. This is going to get the field named something. I don't actually know how to use this function, so we're going to figure it out. Just give it a name. Cool. And that's going to return a field back to us, which is a fun little C# type, which is actually storing metadata about a field, which is kind of cool. So field is going to have all sorts of other fun stuff in it, like the type and attributes attached to it. So for example, when you do fun stuff like serializable or a serialized field or whatever, when you do this, in order to get that out, you can use reflection. So yay. So we have this field. Let's actually see. Well, if this is not null, we know we found it. Otherwise, let's do a property search. Does this make any sense? It might not. Hold on. Let's grab your type. None of those look correct. Field info. There we go. All right, so we're going to use some reflection stuff. Go into here. Member info, that might be what we want. So we are going to create a function that's going to return some member info to us. Member data. And so the reason we're going to create a function is because if I don't find it with a field, I want to check a property as well, because Unity kind of uses both of those independently. And so it might be in a property or it might be in a field. You shouldn't care. As you're typing these things out, you shouldn't care where it's stored, whether it's a property or a field. It should behave the same way to you. And so as part of that, we're going to put this in there, and then theoretically a property info is also part of member info, which means that we should be able to get all of that stuff back out. And this should have everything we need. It has the name, and that should be it. That should be what we need. So I think this is going to work. I've never done this before, so if it doesn't work, well, oops. But yeah, I'm pretty confident, or not. So let's extract this out like so. And why did it just delete the thing? Oh, okay, that's weird. Get what did it call itself? Get member by name. Sure. So we're going to get a member by name from a component, and the name is going to be observed field. And we want to output that there. So we're just going to return here. I'm just going to make this as quick as possible. We're going to only use fields for now, and then I'll add the properties after I get this compiling. So member info. We can move this back to a var, and that will just dynamically type it or automatically type it, figure out the type for us. And it doesn't like the fact that it is only taking one component. Let's actually just make this take a single component, like so. And then we have our observed field. Let's rename that because we're using member everywhere else. So let's just call this the observed member. And so this doesn't seem to like itself because there's only one argument. Let's give it a string here. Observed name. Member, sure. And so that fits there. Our component fits there. We get the type, we get the field. Cool. So that all makes some sense. So effectively what this is going to do is if I have a class called something, good class name, if we have a field that is a public vector3 test, if I gave this test for and was looking for the vector3 component, or was looking for the something component, this should find the test and return the information about this, which will mean I'll know that it's a vector3 and I'll know some other stuff about it. Make sense? I don't know why I asked that question. You can't respond. If it doesn't make sense, leave a comment and I'll see what I can do. Reflection can be weird, especially if you're not familiar with it. It's just something you kind of have to like dive into. So hopefully we're doing that here. But we need to change this because I don't think this is going to work. If we have a property, this doesn't make any sense. So instead of doing all that, let's do a member info equals this. And if our info is null, then info is going to equal component get type, not like that, and get property of observed member. And then we can return info. So if info is null after all of this, we don't have one that is a field or a property. It will search for fields first and then properties, just because that's typically what people use in Unity. They just tend towards fields. But if they don't find it, they'll try a property. So we'll try both. You can't have them overlap, so this shouldn't miss anything. So that makes sense, I think. We'll find out. But this is going to get our member name. If info is not null, then we'll do some other stuff. And so what we need to do, first we need to validate that it is a vector3. So if it's not null, if info dot get member type instance or is a vector3. Can I use that like that? No, I can't, because that's going to be a type, not okay. Dot well, shoot. This isn't exactly what I want. So I could do is equal to member type is equal to a vector3, like type of vector3. There's a problem with this though. If it isn't even going to let me do that. Oh, wait, hold on. Member types is something totally different. That's going to be an enum, isn't it? Oops. Let's do something different. reflected type, declaring type. There we go. Is a vector3. Work. Yeah, add braces. Cool. Okay, so what I was talking about, if I was doing an equal, and so if I was saying if the type is equal to vector3, that will work as long as the type is a vector3. If you have extensions of things, so if you have something that is an extension of something else, using equals won't work because you'll miss everything that extends it. So in order to catch that, you can use is. Is an operator that actually checks if the declaring type is a vector3, which will mean if it inherits from it or anything else. So if it can fulfill that contract, it's good. This is never true though, because this isn't how you're supposed to compare types like this. Let's see here. Inherits is instance of type. There we go. So we can't use is here because that's a type. That's not how that works. You compare an object to a type with an is operator. Since we have a type, we can't compare type to type because it's of type. Yeah, that made sense. Let's just leave that line there. That's great. All right. So instead we can do is an instance of type, which is going to take a type and say, are you of this type? And we give it a vector3 and it should come back and be like, yes. And if it is, then we're golden and we can actually do this stuff. Otherwise, it's just going to skip over it. So now that we have the vector3, the idea here is to pull that out and actually figure out how to assign it and get the value. Right? Okay. I don't know what I was waiting for, but there we go. Info dot declaring type. Don't really know how to get the value out, so what did I do? Get member by name. Okay, the name's there. Reflected type module is defined. How do I get the value? I'm gonna have to look that up because I don't think it's module. That doesn't make any sense. Member type doesn't make any sense. Reflected type doesn't make any sense. I don't know. So I'll be right back. Okay, we may have abstracted ourselves into a bit of a corner here. So there's no get value for member info. There is, however, for get field. So if I do this back to field info, just quickly, I can do info dot get value. It's right there. It doesn't exist on member info, so we're gonna have to do some magic, which is not ideal, but it should work. So what I'm thinking is not something that I'm super I'm hesitating here because I don't really like it and I'm trying to think of something really quickly. But I think we can, I don't like this, get the value. So this get value of member info gross. So let's get that as a vector3. Oh, that's not what I wanted. And I'm just going to kind of mock these functions out. Get the value and then set value of member vector3 like so. Info and then pass in the actual new value. I think that makes sense. So the idea here is get value of member is going to get the value from the member that we have, which means we're going to cast it back to what we had. That's why I was hesitating. Because I don't like that, but it should work. And so the idea here is I should be able to switch off of the info get member or member type. And so if case member types dot field, if we get a field back, it's field, which means I can cast it back to this field. If I can cast it back to the field info, and it should be good, right? So I should be able to do return field info of info dot get value, right? I should be able to do that. I need the object. Let's do that. I need to pass in the object. So the reason this is asking for the object is because I have the type information, which is like, the type is the big grand old thing, which is like if I have something that is describing all cars, if I say, what's the value of that? I have no idea what the value of that is. So we need to actually give it a specific car that we want the position of, or the value of. And so this isn't going to work. I need a object, and we'll just call it the source. And we're going to need that on the set as well. But we don't have the set yet, so we can kind of ignore that for now. Because that's always a good idea. Let's do component. What did I call you? Component. There we go. And so we're taking the component and actually setting the value. Why don't you like that? Can't convert to system.object. What? Why not? Okay, sure, that works. This is a system.object though. I think what's happening is when I do .object, I don't think it's finding a system.object. I think it's finding a Unity engine.object. I think that's what's causing that problem, but I could be wrong. Anyway, we're just going to use the keyword there. Object, there's the source, get value, give it our source value. So that'll take the actual component and say, get the value for this field, which should return t, whatever t is, which means I need to cast this to t. Does that work? Sure. I guess that works. We're just gonna pretend and move along. So we need one more for member types dot property. Return t. Let's just copy this. And this will be our property info. All this stuff is the same, except get value is different. Source index, don't know what that means, so we're going to give it a 0. Doesn't work. Okay. Why not? Why is this different? I have no idea. Okay. So get method. Great. Okay. There's some way to get the thing. That is the best name ever. Get method. Get set method. Yep. I like this. Okay. Enough of that. So I need to figure out what this index is. I have no idea, so I think we're just going to give it a null, because I'm pretty sure we're not using properties. And if we are, then oops. But for now, that'll probably blow up in my face. Cool. And then we need a default case, because otherwise this is not going to work. So, of course, with all default cases, we'll just return null, because that's always safe. Or not, because we can't make t nullable. Default value? Does that make sense? Should we give it a default value? T default value? But then the tool needs to know all the default values for all the different types, which doesn't make any sense because you may have different things. Let's do the actual default of T. Does that work? Yeah. So what this is this is a C# feature, which is going to create the default type for whatever T is, which means if you give it like an int, it's going to be 0. If you give it a class, it's going to be null. But it's going to give you a default type of whatever type you give it. So the advantage of this is regardless of the type you have, you can get a default value, and it'll be whatever is specified for that object, which should be pretty safe-ish. Yeah, we're definitely being safe here. So that should be good, right? No, sure. Let's make this one now. Right, so this needs to actually set the value back, which should be relatively the same. We do need our object again, though. So component, and there's our input, and then we need our object source. There we go. This is going to be very similar because we're going to need to do all these switch things again, just in the opposite direction. Yay. So we don't need the return because we're not returning anything. We're just going to take field info, set the value of source equal to the input. Oh, that's not even close to right. Input. I think those are in the right order. Object and value. Cool. So that's all we need to do. And then I need a break. Because switches. So here we're just gonna do nothing. Break. Cool. And then here, same idea. We're probably gonna get another one of those null things because I don't know what I'm doing. And then input. Nope, that doesn't work. It's out of order. We can fix that. And it's falling through, so break. There we go. So the idea here is exactly the same as the gets, except now we're setting the value, which means we give it the component we want to set and the input that we want to set it to. So I'm saying for this component, set this field to this value. That makes sense. And since this is all chained together, we're setting the output of this, which has the get. So it should just be a giant loop, theoretically. Which means, if I did this right, maybe. Clearly I didn't do this right, because that's not what I wanted. Let's clear this and do position. That worked well. Okay, what did I miss? Something. So if info is null, declaring type is an instance of vector3. I imagine we're going to hit this, so I'm just going to put a breakpoint here and just attach a debugger, and we'll see what happens. I'm curious whether I'm filtering things out prior to hitting any of my reflection stuff, or if my reflection is wrong. Both of those are options, but I need to figure out which one. So we select that, hit here. So if I step over this, if I get inside of this if, then things are good. Otherwise, position is not correct. So if I go in here, I should see the property type is vector3, and I'm looking for a type of vector3. So I would expect it to go into this. If it doesn't happen, my condition is wrong. Okay, condition's wrong. That was easy. So I think we just, is instance of type. Oh, do I need to give it an actual object there? Because that doesn't expect a type. Is assignable from a vector3 is defined. I think that's what I want. Type of vector3. And I think, can I just leave it like that? Nope. Inherit true. Whoa! Hitting all the wrong buttons. All right. So let's actually correctly do all of that. And so is defined should check the definition of the type and see if it's defined as either inheriting from or being part of a vector3. That's like 2 years ago knowledge about how this function works. So let's actually see if I'm right. I think I am. And so we should be able to just step over this now. And it doesn't work. Crap. Why not? All right, I'm gonna go look this up and actually compare types because I don't know what I'm doing. And wait, declaring type, transform. Oh, declaring type. Well, that's right, it's wrong. Okay. Reflected type. Attach a debugger, start Unity. Pretty sure I've got this right now. There we go. Reflected type. Transform. Huh. Well, that wasn't what I expected. Okay. I'm running out of options here. Reflected type. Member type. That's totally different. Declaring type. Also different. Get type? That doesn't make any sense because get type is a C# thing that would return member info or field info or whatever. So I don't want to do that. Can I just do is defined off of this? Let's find out. What could go wrong? I mean, we're already figuring this out. I don't know. Sometimes I like doing this just to kind of see if how good my knowledge is on this kind of stuff, because I don't know. You don't always have the documentation, so let's see here. Step over. Property type. Okay, so it is a property. That's going to be another problem because it's property, which means we're going to have to figure out what that thing is. It also means there's a type that I'm not seeing, which means we need another one of those really janky functions. I think I abstracted this wrong. We're going to carry on though, but I may need to go back and flip this around. We probably abstracted it too early by pulling those functions out. I defined something that I don't think I like. So this makes it nice and clean, but because we did it this way, it means that I had to write all of this stuff. And we need another one for getting the type. Private get member type, which is going to return a type like so. Field dot get or dot field type. There we go. Return that. Great. Gross. Property type. And let's return that. And default can just return null. I don't think that's going to work. Okay, it does. Great. So now I've created a null pointer exception. That's fantastic. Let's just skip right over that and go here. So I want to get the member type for info like this. And then dot is defined like this. Great. Get member type, info. Why doesn't it like this? Because I made it generic, because I wanted it to be generic for whatever reason. We're just gonna ignore that copy and paste and continue on. So now this should get us a type. Then we should be able to check if it's defined by something. And then we should actually get to our actual problem. Great. This has gone perfectly. So Unity should compile there. We'll hit our breakpoint. I want to actually step into this so I can actually see what's going on here. Step over, hit a property, return, and why? I don't know how to see the return type. This was a waste. Cool. And then, now that we have all of that, we should be able to jump in. Nope. Okay. I need to print that out because I had no idea what I was doing. Great. Blarg, I think is the correct response there. So var type equals that. Grab our type. This is all a mess, but that's all right. We're gonna clean all this up. It's okay if your code gets really gross. You can clean it up later. So this isn't super bad. We're still figuring the problem out, so it's probably a good thing that we didn't try to make it super clean, because that usually just doesn't work. You saw what happened previously. We ended up with all these because I tried to make it cleaner. So generally holding off on abstractions until you understand the problem is usually the best. And I'm kind of learning that here. So I don't need to print it. We have a debugger. This should say vector3. And if it does, I'm confused why this doesn't work. Unless I'm using the wrong function again. Dot is. I feel like that's the right type. Is instance of type. But what's it called? Is subclass of. That might be correct too. Let's give it a try. Because we're just guessing anyway. So what could go wrong? So anyway, now that we do all of this, I should at least be able to see the type. Once I can see the type, I can figure out if this is going on and if I need to actually look up the documentation. We're getting vector3 here. Or if I need to go do something else. Since we're getting this, the function I was using was being used incorrectly. So this might work, or I may need to go and look up the actual correct function to use because that is what a responsible person would do. Let's go do that. Well, I don't know what's going on. I thought this would work. Is subclass of. I tried pretty much every function here. There were a bunch of suggestions. Some of them I didn't like, but none of the ones I did worked, so I'm confused. What I do know will work, though, is this. You know how I talked about how I didn't want to do this? But we're going to do it for now, because I just want to move forward, and this will get us past it. This is kind of a silly problem, because we don't really. It's going to go away. Eventually, we're just going to check this type and use that to actually generate different field things, different UIs, so you can actually see like vector3s versus string fields versus numbers, etc. So this is not a long-term problem. So trying to continue to force our way through it doesn't really make any sense. So we're not going to. That's the basics of it. So this will at least work for vector3s. Which means anything that inherits from it probably isn't going to work, but oh well. So I should be able to open Unity now, and assuming all of our stuff works, I should get that, which is great. And then I should be able to do something like local scale. Huzzah! So I can now type in anything and get either the property or the field of it back and actually edit them. Which means if I change the directional light to say have a 27Y, don't know why I do that. If I go here and actually look in the inspector, our scale is 27, which is great. And then I can change it back and then select this and we get back to it, which is perfect, which means I can see all of these things in real time and kind of edit them as I want to. I don't think rotation will work because that's a quaternion, which we don't support yet. But everything else works. So I can do like position. I don't know if there's anything else really that uses this. Local position is an option. So we can edit the local position. This is going to be exactly the same because they're parented to the scene. But anyway, it works. So now we have reflection, which actually means we can actually look this stuff up and change it. So the next step is actually being able to find components. And then after that, we should be able to use things other than just vector 3s. So 2 more steps, and then we can add some more extra stuff on top of that. But I think this is a good progress because this actually makes it a little bit more useful. Maybe not so much for transforms because there's not much there, and particularly for vector 3s, but for now this is sort of a good stopping point because we're pretty close to being able to make this very useful for other things. And so that's where we're going to go next. But I'll leave this here for now. So unless there's, yeah, I think that's it. Anyway, if you guys have other questions or have suggestions on how I could compare types, that would be great because I don't like this. So if you guys know a better way to do this, that'd be great. I don't think is works because you can't use is to compare 2 types, to my knowledge. It really doesn't like that. So I don't know a better way to do it. So if you do, let me know. Otherwise, we'll probably have to clean this up at some point because this is gross. But we can do that later. So I'll leave this here. I'm hoping to open source this soon-ish, probably this weekend. So yeah, if you guys want to contribute back to it, you can do that when it's available. Otherwise, if you want to come join our Discord, there's a link in the description where we kind of can talk about this stuff. A lot of people have cool either projects they're working on that they share or other things that they have questions on, etc. So if you want to join that, go for it. But that's it for this video. So until next time, see you, Internet.